Okay, all right, guys. Welcome to this project on recursion. All right. I'm all good out here. I believe you are enjoying your coding journey. Okay, today we are looking at recursion. By the way, if you are just coming across this channel, please like and subscribe and give our video a thumbs up. And if you are a returning subscriber, please watch this video to the end. This topic about recursion, we'll be doing our best to ensure we break it down, piecemeal, so that you can grab and understand what it is and what it's talking about. All right. So uh, before we do any other thing, as usual, let's look through the quiz questions. We are going to break down some concepts about recursion, and we'll be solving all the tasks. And I will try my best to, bring it to the level where you will understand, have a better comprehension about this topic. All right, I promise you that. Okay, so let's quickly see the quiz questions. I might not have time to explain them, but I'll just show you in case you are having challenges completing that. So for this is it. Then for question one, is right here. Question 2, this is it. And for the third one, question 3, this is it. Then the last and not the least, question 4, that will be 21. All right. So because of time, I'll just go ahead to do other explanations. All right. So I'll have to hide the quiz session. Okay. All right. For the project proper, before we go on, please do your best to look through these resources. They are very educative. You are going to learn a lot from them. Okay. Then read through, of course, before you start your project. Always go through the requirements. All right. Before I do any other thing, let us look at one of the resource. The concept about recursion. What the hell is recursion? Recursion is the process of repeating items in a self-similar way. Okay, like looping, repeating items in a similar way. And in programming language, if a program allow you to call a function inside the same function, then it is called a recursive call of the function. All right, you have two functions, or you call one of that function inside the other. That is a recursive call. Okay. So C programming supports recursion, that is function to call itself. All right. So in C programming, recursion is supported. Okay, and in doing that, you have to ensure that you have an exit you have an exit condition for your loop. All right, so that the function will not continue to run infinitely without ending. All right. So recursion is applied in different areas. All right, you can use it in mathematics to do your factorial, to get the factorial of any number, and you can use it for Fibonacci. All right, for Fibonacci. Okay, so applications is really good. Okay, so that is a little explanation about recursion. Okay, before we go on, again, let me do some fancy explanation. Alright, I'll just expand this. So since we have looked into what recursion is, like we said, it's a function calling itself. Okay, that's recursion. All right, so let us explain something, since one of the application of this is getting the factorial of number. That is our case study. All right, so let's say we have we want to determine the factorial of 4. How do we go about this? All right, how do we solve this? Okay, in recursion, we are trying we try to determine, okay, a complex, to solve a complex problem by first solving, you know, the less complex, the smaller problem, then we graduate to get the, you know, the value for the solution to the bigger problem. That's what it's all about. So look at this as a case study. 4 factorial is what? I don't know what that is. All right, so but I know that, okay, 4 factorial is 4 multiplied by times 4 times 3 factorial. All right, again I have a problem. I cannot determine the value, the final value for 4 factorial, because 3 factorial is not known. 3 factorial is not known. Again, I come down here, I do 3 factorial is 3 multiplied by times 2 factorial. Again, I cannot determine the value for 3 factorial because I have a challenge here. I don't know the value for 2 factorial. All right, then I come down again, 2 factorial. 2 factorial is 2 multiplied by 1 factorial. Again, I will have to really determine what this value is to be able to get the actual value for 2 factorial. So I bring it down here again. 1 factorial is what? Is 1. All right, 1 factorial is 1. All right, keep that in mind. And again, you should know that 0 factorial is also what? Is also 1. Okay, so how do I now determine this? So from what we have done, we can now scale up to get the final value for this. We can now get the final value for this because we have broken it down piecemeal to the final, to get the value of 1 factorial. So we can now move up to get the value of 4 factorial. And from what we did here, 4 factorial will be what? 4 factorial will be what? 24. How did we get that? That will be 4 times 3 times 2 times 1. That will give us what? 24. So to get the factorial of any number, we do n times multiplied by factorial n factorial. Please manage with us. We are doing freehand. This is a pencil drawing. N minus 1. All right, n minus 1. So that is how we arrived at all of this. N times factorial, whatever that is, subtract 1 from it, so to help you get the factorial of any number. So I believe this should, I have tried to break this concept down so that for you to get what the value of this is, you have to break it down to this point. And when you get the final value of when you get the final value of 1 factorial, you can now go up, scale up, and get the value of 4 factorial. All right, so I believe that should help in a way to understand this concept about factorial. Okay, so let's move on to solving the project task. We create our files. Okay, Okay, so again, always ensure you go through the project requirements time and again to ensure you are doing the right thing. All right, so since we have our terminal open, the next thing is to create, one of the requirement is to have a readme.md file. So I'll just go ahead and create that. All right, so before then, we need to navigate into our repo. So I'll copy this. First, you need to be sure you are in the root, all right, in the root directory. So how do you do that? cd/root. So I'm very sure I'm in the root directory. So I move to the ls. So I'm in the ls low level programming directory, or repo as the case may be. So I'll then create this directory, all right, is 0 times 08 recursion. So I'll copy it, I come here, I do mkdir make directory, control av, I paste that. If I press enter, it's going to pump an error saying that I have that. Let's just do that. I press tab. So you see, it said cannot create directory because this already exists. So I already created that before now. So since I have that, the next thing, you can go ahead, do that, make mkdir make directory, and you do that. It's going to work. It's not going to pump up this error. So since I have that, I'm going to cd into that directory. So I paste the file name, the directory name rather, I press tab. So you see, we are now in the 0 times 08 recursion directory. All right, so we are now in the 0 times 08 recursion directory. So once you make directory, then you cd into that. So since we have done that, the next thing we are going to do now is to create a readme file, since it's a requirement. So how do we do that? We're going to use vi this time. Do vi readme.md. All right, vi readme.md. If I press enter, so it's going to bring this up. This is the content of my readme. How did I come about this? What I did was just to go ahead and copy the file, the questions. All right, so you can see this. She locked away a secret. So that's what you have there is 0. So after that, I copy this and put that here. So that's what you have here. And the next, just like that, that's how I copied, put them in my notepad. Then from my notepad, I copied everything and pasted here using Control A, alight or copy. Then come back to my terminal and do Control AV to paste everything. It's just as simple as that. I just needed you to know that. So if you do that successfully, then you can now exit this file by doing escape :WQ. I'll just do Q since I'm quitting. So since we have successfully created a readme file, the next thing to do is to create your main.h file. All right, so we are going to use vi again, vi main.h. all right, so I press enter, main.h. So this is the content of our main.h file. Okay, so how did we come about this? Our main.h is just a combination of our project prototypes. Okay, it's a combination of our project prototype. All right, so for this first one, you have an int, then put char, then character. All right, which is a car. Okay, for the first one. Then for every other one, it was copied from here. You can see the prototype. For the second one is void put recursion car multiplied by s. Then you have the next prototype, which is same as what you have here. So that's just that. All right, you can move to the next. It was copied from here. So it was not taken from the blues. It it was gotten from here. Actually, you can just do same, put them out and put them into your main.h file. So when you do that successfully, you can exit column wq. In my case, I'll just do column q since I'm quitting. Oh, sorry, escape, column wq. Alright, so once you do that successfully, then you can now push your main.h to the remote repository. So how do you do that? You do git add dot, you press enter, then you do your git commit -m, control your commit message, which this time is main.h. We are pushing main.h. So of course the proper name for the commit should be the file name. That's what we do here. So after doing that, you press enter, then you can now do your git push. You press enter, so that will push main.h to the remote repository. So after doing that, you can, yes, after successfully pushing your main.h, you can now go ahead, since you've created a readme.md and main.h, then you can now go ahead to start solving the individual tasks. Alright, you can go ahead to start solving the individual tasks. But before then, let me show you quickly. I just showed you, I explained using the Factorial, using Factorial to show you what recursion is. Let's use a proper program, a C code, to explain that. Alright, so let me come here. I'm not saving this. So alright, so from what we explained earlier, of course this is a C program. Okay, you include standard input output, the header, then here you have your, we used unsigned int, it's a type of integer. Then you have Factorial, which is the name of the function. You have a function name, then you have the argument, the function parameters. Alright, then call your curly brace, then you have the conditional statement here. If n is less than or equal to 1, return 1. Alright, whenever n is less than or equal to 1, return 1. Otherwise, return n times what? Factorial n minus 1, which is, which we said is the formula for calculating factorial of any number, right? Then you now have the second function inside this first one. Okay, so integer main, it's our function name, then no argument, then printf percentage I n, which is a parameter, a variable, sorry, then factorial 4. We want to determine the factorial of the number 4. I think I need to close. I need to close. Alright, so let's just take this to, I'll copy this, I'll come to one of our IDE here. I'm using Replit here. Okay, let me just remove this. Sorry, let me expand this. Okay, so I'll paste in that code. We are determining the factorial of the number 4. Alright, so let's run it. If it's going to give us that value we got when we are explaining manually. Alright, you see, this gives us 24. So the factorial of 4 is 24. So this is a recursion program. Okay, so let me change this to 5. Of course, you should guess what that should be, because the factorial of 5 is going to be 120. So you can use this, to determine the factorial of any number. If I do 12, that will give you this. Alright, so that is that. Alright, so I just need to test this out so that you understand how it works, so that when we start solving the task, because it will be quite fast, you'll not be confused. So this is it. So I'll just restore this down and we move on with solving the project task. Okay, so since you've created our main.h and readme file, the next is to start solving the task. So for the first one, I'll just go ahead and copy the file name, Ctrl C. I'll come here, do vi, Ctrl AV, I'll paste that in. So this is the content of your file. For the first one, 0 put recursion.c. So put this content into that file. When you are done, you can do your escape, :wq. I'm just quitting, so I'll use :q. So once you have done that, you can do your Betty, your file name, to ensure that your code is Betty compliant. Of course, it has shown Betty did not show any error, so our code is Betty compliant and follow the Betty documentation style. So after doing that, you can do your git add dot, you press enter. Then I'm not doing that again since I already pushed. I'm not ready to push my code twice. All right, git commit commit message. Of course, we always use our file name. You press enter. Then after that, you can do git push. You press enter. It's going to push that code to the remote repository. All right, so once we are done with that, you can now go ahead to check your code. So if I run this check, as you can see, it's correct because we followed the right process. Okay, so if you do this exact same thing, you're going to get the same correct result. So I'll quickly move to the next task, which is this. So I'll copy this, the file name. I'll come here, I'll do vi, paste in that, I'll press enter. So this is the content of that. Of course, you have your header file, your what's it called, your comment section. Then you have your function and your recursive function, a function inside a function. So this is it. So put this into that file. When you are done, you can escape :wq. All right, so again, you do your Betty file name, you paste that. So Betty says we are good to go, so you can do your git add dot, you press enter, git commit, commit message, commit message, you press enter. When you are done with that, you do your git push. Like I said, I already pushed before, so I'm not going to push again. So once you have done that, you click on enter. It's going to push that to the remote. So if you've done that, you can go ahead to check your code. So if you've done that correctly, you're going to get the same result. So I'll close this, move to the next one, which is this. So I'll copy the file name once again, Ctrl C. Let me clear here. So I'll do vi, file name, paste that, press enter. So this is the content of that file. Put this in. All right, this is the content of that file. Once you are done, you do escape :wq. I'm just using :q since I'm not saving. So done with that, you do your Betty, the file name. So our code is Betty compliant and follow the Betty documentation style. So we are good to git add dot, you press enter. Then you do git commit commit message, press enter. Then after that, you can do your git push, you press enter. If you do that successfully, you can go ahead to check the code. So if I run this check, you see it's all tick green. That means we are correct. So I move to the next one, which is this. Write a function that returns the factorial of a given number. So again, I copy the file name, copy, I come here, I do vi, Ctrl A V, I paste that, I go into vi. Alright, so this is it, this is the content. If n is less than 0, return -1. If n is exactly 0, return 1. Return n s. If not, then return n times factorial n minus 1, similar to what we explained earlier. So of course this is the header, and this is the comment, code comment. So put this into your file. Alright, once you are done, you can escape, column WQ. I'll just do Q now. So once you are done, you can go ahead and do Betty, but time is fast spent, so I'll just go ahead and do git add dot. Since I already know this particular code follows the Betty style, dot git commit, commit message. Of course, here we use the file name. Then once you are done with that, press enter. Then you can now go ahead and do your git push. So once you are done, you hit enter and come back here to check your code. So you see, that is correct. Alright, that is correct. So let me close this. So for the next task, we are going to write a function that returns the value of x raised to the power of y. Alright, so I'll copy this file name, Ctrl C, I come here, I do vi, Ctrl A V, press enter. So of course, put this content into that file, then you can do escape, column WQ, press enter. Then you can of course do your Betty, Ctrl A V. Okay, Betty says we are good to go, so let's do git add, enter, git commit, commit message, enter, then do your git push, press enter. Once you are done with that, you can come back and check your code. So our check says it's all correct. So if you follow exams, if you go through this, you are going to get the same result. So for the next one, write a function that returns the natural square root of a number. So once again, we copy the file name, come here, I'm going to do vi, paste that, press enter. So this should be the content of that file, starting from here. Alright, this should be the content of that file. That's not the end. If I page down, okay, it ends here. Alright, it ends here. So that's it. So once you have done this, the next thing you do is once you have inputted the right content, you escape, then do your column WQ. I'm just going to do column Q since I'm not saving. Alright, so you can of course do your Betty, Betty says yes, we are good to go. Then you do your git add dot, press enter. After that, do your git commit, commit message, you press enter. Then once you are done with that, you can do git push your code to the remote. Done, you press enter. Alright, so if you followed that step rightly, you can come here to check. Again, you see it's correct because we followed the instruction, we did the right thing. You can do the same thing too. So for the next one, write a function that returns 1 if the input integer is a prime number, otherwise return 0. So copy this, the file name, come here, vi, Ctrl A V, you paste that. So again, this is the content of that file. All right. Not the end though. You do page down. So it ends here. Ends here. All right. So you are going to input this into that file. Once you are done, you do your escape, column WQ. All right. To save and quit. So you can do your Betty. Do your Betty. All right, Betty file name. So I know that this code follows the Betty style, so I'm just going to add with add dot enter git commit m commit message, you press enter, then after that you do git push and press enter. So once you have done that successfully, you come back here, you do your check, it's running, is correct. So if you follow that, you are going to get the same result. Move to the next, write a function that returns 1 if the string is a palindrome and 0 if not. So again, I'll copy the file name, Ctrl C, come here, I'll do vi, Ctrl A V. So again, this is the content of your file. Okay. So this is the content. This is the beginning of that file. So include this code. This is not the end. Just move down, do page down. Okay, so it ends here. So put in this code into that file. All right. Once you are done, you can do your escape and do column WQ, or just do column Q6. I'm not saying I'm quitting. So you can go ahead and do your Betty file name. Betty is checking. Betty did not return any error. So it's all clear. So let me clear here. So you can now do your git add dot, press enter, then git commit and your commit message, enter, then finally you do your git push. Not pushing again, this already pushed to the remote. So after doing git push, you press enter, then you can now come here and check your code. So you run this check and you see our checker is all correct. All right, you get the same exact same result if you follow that step we aligned there. So move to the last, I believe the last task, which is this. Write a function that compares two strings and return 1 if the string can be considered identical, otherwise return what? 0. So come here and copy this file name, Ctrl C, I copy that, I come here, I do vi, Ctrl A V, I paste that in, I press enter. Alright, so this is the content of your file. Sure you put this in, starting with this header, include main include main.h. Alright, put this in. It ends here. So put this content into the file. All right, once you are done, you can do your escape column WQ, save and quit. You can go ahead and check for Betty. Ooh, yes, Betty said we are good to go, so you can do your git add dot, press enter, then git commit message, because our file name. You press enter, then you can now do your git push, press enter, git push, you press enter. Once you have done that, you check your code. All right, you can see this, it's all green, it's correct. So once you have done that, you get same result. Please, if you follow through to this point, congratulations, because you are going to ace this sax. All right, please give this video a thumbs up and like and subscribe to this channel. There are more interesting projects coming up. All right, I love this Recursion so much. More interesting projects are coming up. Subscribe to this channel and you'll be in the known whenever we drop a video. All right, so glad to do this right now. Definitely see you in the next one.